continuing with our introduction to trigonometry, we have a couple standard terms that you need to be aware of. So first of all, when we are measuring angles, we often like to talk about them in a circle. And furthermore, we often like to put the circle on an XY plane. This allows us to use X and Y coordinates, and it just gives us more tools to talk about things. Now, we always put the center of the circle at the origin, okay? And there is a special way we like to draw our angles. It's called standard position, and it is that the initial side of the angle always rests along the positive x-axis, and then you turn from there. So if I were doing a negative angle, I'd turn clockwise. If I were doing a positive angle, I'd turn counterclockwise until I end up at whatever my terminal side is for the angle. Okay? So our angles are always going to start at the positive x-axis and move from there. Now, we have a couple special kinds of angles. An acute angle is one between 0 degrees and 90 degrees, or in radians, between 0 and pi over 2 radians. Okay. An obtuse angle is one between 90 degrees and 180 degrees, or in radians, between pi over 2 and pi radians. And of course, there's a right angle, which is exactly 90 degrees or pi over 2 radians. Okay. These are special classes of angles that will come up often. Now, there's also special classes of angles when we're talking about them in pairs. So, complementary angles are angles that add to 90 degrees or pi over 2 radians. Okay. Supplementary angles are angles that add to 180 degrees or pi radians. Okay. So, as an example, let's look at 67 degrees and 2 pi over 5 radians. Okay. And I want a complementary and a supplementary angle for both. Now, 67 degrees, in order to add to 90, I'm looking for the angle that is 90 minus 67 degrees, or 23 degrees. In order to find the supplementary angle, I'm looking for 180 minus 67 degrees, which is 113 degrees. Now, in radians, I simply use the radian version, so I'm going to do pi over 2 minus 2 pi over 5. Unfortunately, radians tend to have fractions more often than not. Makes life a little bit interesting. This is pi over 10, because 1/2 minus 2/5 is 1/10. And then I'm going to do pi minus 2 pi over 5, which is a little bit easier to handle, because 1 minus 2/5 is 3/5. And you'll notice I just put a pi on everything and let it carry through. There's one other class of angles that I want to talk about, and that is coterminal angles. Okay. Now, coterminal angles are if in standard position, their terminal sides are identical. So, consider, for example, the one I already have drawn up here, this angle with initial side in standard position and then terminal side. Now consider the angle also in standard position, so starting there, and doing this so that its initial side lines up with the orange one. Even though in motion those two angles are different, because the second one round around once, those two angles look the same if all you see are the initial and terminal side. They're called coterminal, meaning same terminal side. Now, there is more than one coterminal angle for any angle. In fact, there's infinitely many. And there's a pattern, because as we saw, for them to be coterminal, they must differ by a full circle. So in degrees, you take your angle and add a multiple of 360, And in radians, you take your angle and add a multiple of 2 pi, a multiple of the full circle. And by multiple, I do mean negative multiples as well. So I'm going to give you a single example of coterminal for each. For this one, I'm going to take 67 degrees and add 360 degrees to it. And this gives me a coterminal angle of 422 degrees. For this one, I'm going to take 2 pi over 5 and subtract 2 pi from it. And this gives me a coterminal angle of minus 8 pi over 5.